Hi children, good morning all of you. Yesterday, in the previous video, we discussed the theorems based on alternate interior, co-interior and their converses. Like that, I will briefly explain alternate exterior and co-exterior angles and theorems based on those. Here, if a transverse intersects two parallel lines, statement this one also. If a transversal intersects two parallel lines, then the formed alternate exterior angles are equal. Another thing, this one. Already completed transversal intersects two parallel lines and the formed alternate interior angles are equal. Now exterior angles. Here L is parallel to M and N is a transversal. Here A and B are alternate exterior angles and C is another angle. Here hypothesis. L is parallel to M and N is a transversal. N is a transversal and angle A comma angle B are alternate exterior angles. Alternate exterior angles. Conclusion. We need to prove angle A equal to angle B. Alternate exterior angles are equal, we need to prove. Proof. We have angle A equal to angle C. First statement, corresponding angles. Corresponding angles axial. Next, angle B equal to angle C, vertically opposite angles. Vertically opposite angles. From 1 and 2, equals of equals are equal, meaning A equal to C and B is also equal to C. Therefore, angle A equal to angle B. That is only our required proof. So, hence proof. If a transversal intersects two parallel lines, then the formed alternate exterior angles are equal, we need to prove. For proving this alternate exterior angle theorem, we require two parallel lines, they gave, and N is a transversal, A and B are alternate exterior angles. They formed, they gave. So, conclusion, angle A equal to angle B because these two are alternate exterior angles. Here, for proving this one, we require another angle, that is C. A equal to C, corresponding angles. Exterior, interior, same side of the transversal, not at same. Therefore, the property, these two are corresponding angles. corresponding, according to the corresponding angles axiom. What is the corresponding angles axiom? If the transverse intersects two parallel lines, the formed corresponding angles are equal. So A equal to C we have. B equal to C, alternate, vertically opposite angles, because here M and N are intersecting lines, and angle C and angle B don't have any common arm. That's why they are vertically opposite angles. Again, the first statement A equal to B, again the second statement B equal to C. With the help of these two conditions, we have A equal to C and B equal to C. Two things are equal to the same thing are also equal, or equals of equals are equal. So A equal to B, that is the required proof. Okay, next. Next theorem, statement. If a transversal intersects two parallel lines, then the formed coexterior angles are supplementary. The formed coexterior angles are supplementary. In the case of co-interior and co-exterior supplementary, for the remaining equal. Only for co-interior and co-exterior angles are case, the given angles are supplementary. Here P is parallel to Q and P is a transversal. Here angle small a and small b, or small x and small b, all are A and B mean here x and y. Let it be another one, Z. Now hypothesis. Here P is parallel to Q, T is a transversal, and X and Y are co-exterior angles. X and Y are co-exterior angles. Conclusion: angle X plus angle Y equal to 180 we need to prove. They are supplementary, means sum of any two angle measures 180 degrees, then we can say that they are supplementary angles. Here X and Y are supplementary because they are co-exterior angles. We need to prove there is some angle. Proof: we have angle X equal to angle Z. In the first statement, again to the corresponding angles axiom. Corresponding angles axiom, because here P and Q are parallel and he is a transversal, the formed corresponding angles are equal. So X equal to Z and Y plus Z equal to 180 degrees. That is the second one. Since they forms a linear pair, Y and Z togetherly forming a straight line, that's why Y plus Z equal to 180 degrees. Y plus Z equal to 180 degrees. That's a linear pair. So instead of Z, we replace X from 1. That's why here angle Y plus angle X equal to 180. That is the required proof. Hence proved. Hence proved. That is only the required proof. My next theorem, if you transverse lines is two parallel lines, then the formed coexisting angles are supplementary. Okay, in a plane P and Q are parallel lines and D is a transversal. Here X and Y are coexisting angles. We need to prove their sum is 180 degrees. We have X equal to Z because P and Q are parallel, D is a transverse, the formed corresponding angles are equal according to the Euclid's axiom. And Y plus Z equal to 180 because Y and Z togetherly forms a straight line. Two angles forms a straight line mean they are linear plane. So Y plus Z equal to 180. X and Z are equal. So Z replaced by X mean Y plus X mean X plus Y equal to 180. X and Y are coexisting angles. Their sum measures 180 degrees. Some more important theorems based on parallel lines. Some more important theorems based on parallel lines. Some more important theorems. Before we are going to learn theorems, first of all, bisectors. What are bisectors? We have different type of bisectors. Only bisector mean, for example, the length of line segment is 6 centimeters. Another line CD divides AB into two equal parts. CD into two equal parts mean 3 centimeters and 3 centimeters. So CD is a bisector. Okay, only bisector. Perpendicular bisector mean perpendicular bisector. So now AB is 6 centimeters. CD divides AB into equal parts and making an angle 90 degrees with AB is called a perpendicular bisector. Is called a perpendicular bisector. Bisector mean CD divides AB into two equal parts. Perpendicular bisector means CD divides AB into two equal parts and making an angle 90 degrees with the AB. Equal and perpendicular bisector. Equal and perpendicular bisector means here AB 6 centimeters means 3 centimeters and 3 centimeters. CD, for example, 5 centimeters, they gave me 2.5 and 2.5 centimeters. This is equal and perpendicular bisector. Equal and perpendicular bisector. Only perpendicular bisector means CD divides AB into equal parts and making an angle 90 degrees. If CD also divides it into two equal parts. Okay, CD 5 centimeters, they gave me 2.5, 2.5. AB 6 means 3 and 3. This is perpendicular and equal bisector. These are bisectors. Angular bisector. Angular bisector means, for example, AOB is an angle measuring 60 degrees. And OC is a ray which divides AOB into two equal parts, in 30 degrees and 30 degrees. Then OC is called angular bisector of angle AOB, because OC dividing angle AOB into two equal parts. That's why here OC is an angular bisector of angle AOB. Angular bisector, side bisector and angular bisectors. Now, theorem statement. If a transversal intersects two parallel lines then the formed corresponding angles are equal. You know this one. Then prove that the angular bisectors of these corresponding angles are parallel. According to the corresponding angles axiom, if a transversal intersects two parallel lines, then the formed corresponding angles are equal, we know. But he is asking, prove that the angular bisectors of these corresponding angles, are parallel. I'll draw it. Here L parallel to M and is a transversal. Here A and B are corresponding angles. Those are equal, we know. We need to prove angular bisectors of these corresponding angles. Angular bisectors of these corresponding angles, let it be P and Q. P and Q are parallel, we need to prove. Observe here. Hypothesis. L is parallel to M and angle A equal to angle B. Corresponding angles are equal to U. And P, Q are angular bisectors. PQ are angular bisectors. Conclusion. What we need to do? P is parallel to Q, we need to prove. Proof. Here, what is an angle bisector? It divides the given angle into two equal parts. Mean A divided into A by 2 and A by 2, and B divided into B by 2 and B by 2. A by 2 and B by 2. Mean here angle A equal to angle B, that implies angle A by 2 equal to angle B by 2. Now, what are angle A by 2 and angle B by 2? Two lines in a plane intersected by a transversal. Then the formed alternate interior angles or corresponding angles are equal. The lines are parallel. So, P is parallel to Q. Converse of corresponding angles XC. Converse of corresponding angles axiom. Now we have 4 theorems and its converses also. What are the theorems? If a transverse line sects two parallel lines, the formed alternate interior angles are equal. If a transverse line sects two parallel lines, the formed alternate exterior angles are equal. If a transverse line sects two parallel lines, co-interior angles are supplementary. Co-exterior angles are supplementary. These are theorems. What are their converses? If two lines intersect by a transversal, the formed alternate interior angles are equal, lines are parallel. Formed alternate exterior angles are equal, lines are parallel. Corresponding angles are equal, lines are parallel. According to that statement, here A by 2 and B by 2 are A by 2 and B by 2 are A by 2 and B by 2 are corresponding angles. Here P and Q are two lines intersected by a transversal N. Here the formed corresponding angles are equal. Mean A by 2 equal to B by 2 we got. If A by 2 equal to B by 2, we can say that P is parallel to Q. Corresponding angles are equal, lines are parallel. Alternate interior angles are equal, lines are parallel. Co-interior angles are supplementary, lines are parallel. Co-exterior angles are supplementary, lines are parallel. So their converse is also true. Their converse is also true. So according to that statement, we prove this one. Next. Okay, next one. Next theorem, if a transverse line sects two parallel lines, then the formed alternate interior angles are equal, then prove that angular bisectors of these alternate angles are alternate interior angles for interior and exterior also are parallel. You need to prove. Already you proved one theorem, that's why this is easiest. Here L, M, N. Now alternate interior angles here. Here X and Y are alternate interior angles. You need to prove angular bisectors of X and Y. Let it be P and Q. It divides into X by 2 and X by 2. Here Y by 2 and Y by 2. Hypothesis here X equal to Y again. Okay, L is parallel to M and M is a transversal. These are already known things. Conclusion. You need to prove P is parallel to Q. P is parallel to Q. Here proof we have X equal to Y. So divide by 2 means X by 2 equal to Y by 2. Angle X equal to angle Y. So both sides divided by 2 means X by 2 equal to Y by 2. Here X by 2 and Y by 2 both are alternate alternate interior, these two alternate interior angles. So if alternate interior angles are equal, lines are parallel according to the converse of alternate interior angles theorem. Converse of alternate interior angles theorem, alternate interior angles are equal, lines are parallel, because these two lines are transversal, these two lines are intersected by transversal n, intersected by transversal n. So here x by 2 equal to y by 2, we have x and x by 2 and y by 2 are alternate interior angles. If alternate interior angles are equal, then the given lines are parallel we have. So according to the statement, the given lines are parallel, equal to q, hence prove this statement. Okay, in this way we can prove the given. Now another one. For co-exterior, alternate exterior also can prove this one. Next, in case of co-exterior, co-interior, if you transverse bisects two parallels, then the formed co-interior angles, formed co-interior angles are supplementary. Co-interior angles are supplementary. Angles are supplementary. Then prove that angular bisectors of these co-interior angles forms a right angle. This is different. But different. If you transverse bisects two parallels, then the formed co-interior angles are supplementary, we know. Then prove that the angular bisectors of these co-interior angles forms a right angle. In the previous cases, we proved they are parallel. But in case of this one, we need to prove they forms a right angle, means they are perpendicular lines. In the previous cases, parallel line. Now we need to prove they are perpendicular. If they are perpendicular, right angle forms. So L is parallel to M and N is a transversal. Now here co-interior angles between these two. Okay, we need to prove P and Q are perpendicular lines. Means this one 90 degrees we need to prove. Okay. Now hypothesis angle A plus angle B equal to 180 degrees. Angle A plus angle B equal to 180 degrees. They are supplementary. Mean here A becomes A by 2 and A by 2. B becomes B by 2 and B by 2. Okay, let it be A, B, C. A, B, C. Here we need to prove angle C equal to 90 degrees. Angle C equal to 90 degrees from triangle ABC, because of the intersection of P and Q be C. Here, intersection of P and Q is C. We assume that one. So we need to prove angle C equal to 90 degrees. Here A by 2 plus B by 2 mean A plus B equal to 180 degrees. We have divide by 2 both sides. Then A by 2 plus B by 2 equal to 180 by 2, that is 90 degrees. In here, A by 2 plus B by 2 equal to 90 degrees. From triangle ABC, angle A plus angle B plus angle C equal to 180 degrees. We have sum of the angles of triangle measures 180 degrees. Here angle A in triangle ABC means A by B. Angle B means B by B. Plus angle C down now 180. A by 2 plus B by 2 measures 90 degrees. So 90 plus angle C equal to 180. Therefore, angle C equal to 90. 180 minus 90 equal to 90. Hence, prove this one. Important. Observe this one. Keep concentrate. Here, if you transverse length is two parallel lines, then the formula co-equidistants or co-axis are supplementary we know. Then we need to prove the angular bisectors of these co-equidistant angles. Here, these are co-equidistant angles. Otherwise, these angular bisectors mean this. Okay, angular bisectors of these co-equidistant angles forms a right angle. Here we need to prove they are perpendicular to each other. Means 90 degrees. Here A plus B equal to 180 because A and B are co-interior angles. They are supplementary. Angle C, where B and Q meets, let it be C. That's why angle C equal to 90 degrees we need to prove. If angle C equal to 90 degrees, P and Q are perpendicular lines. They form a right angle. Okay. Now A plus B equal to 180 degrees we have. Dividing by 2 both sides, then A by 2 plus B by 2 minus 90 degrees. From triangle ABC, from triangle ABC, here A by 2, here B by 2 we have. But sum of these two angles measures 90 degrees. According to the given statement, A by 2 plus B by 2 measures 90 degrees. With the help of this statement, we can prove the remaining angle also measures 90 degrees. Because in a triangle, sum of the two angles measures 90, definitely the third angle will be 90 degrees. So angle C equal to 90 degrees according to that one. So angle C is 90 degrees. Okay. In this video, we discussed alternate axis angle theorem, co-axis angle theorem. In addition to that one, bisectors, angular bisectors as well, side bisectors we discussed. With the help of those bisectors, we proved angular bisectors of corresponding angles when the two lines are parallel. That is important condition. That's why I wrote. When the two lines are parallel, then the form of corresponding angles are equal. We know from these corresponding angles, the angular bisectors are parallel. Okay, if we transfer inside two parallel lines, the formed alternate interior angles are equal. We know the bisectors of these alternate interior or alternate exterior angles are parallel. That one also we proved. Now we proved important condition. If we transverse inside two parallel lines, then the co-interior angles are supplementary. We know from these supplementary angles, these bisectors forms a right angle. Otherwise, they are perpendicular to each other. Mean where they meet, that is a 90 degrees. Mean right angle. So angle A plus angle B equal to 180 degrees. They gave. Divide by both sides, then we will get a by 2 plus b by 2 90 degrees. From triangle ABC, a by 2 plus b by 2 90, and another angle C also minus 90 degrees. That is only our required proof. Answer proved is correct. Tomorrow we will discuss the remaining theorems. Have a nice day.